So good morning, Dr. Sun here. I am Dr. Nagina Priyadashni, Professor of EC Department. In today's class, we shall discuss about the various modulations, satellite communication, the basics of satellite communication. First one is Kepler's law. So Kepler's law is just proposed by Johannes Kepler. So it states the principles of satellite that moves around the Earth. So the Kepler's law is formulated of three types, so which covers the entire satellite communication observations. So these Kepler's law are highly helpful to visualize the motion of satellites in space. So first, let us discuss about Kepler's first law. So Kepler's first law states that the path followed by a satellite around its primary will be an ellipse. So, so here the primary object is the Earth and the secondary object is considered as the satellite. So from the definition, the ellipse has two focal points. So that focus point is indicated as F1 and F2. So which is indicated in the following figure. So here the center of the mass, the figure is given here. So here the center of the mass of the Earth, that is the larger body, that will be always in any one of the focal point. So if the distance from the center of the object to a point and its elliptical path is considered, then the farthest point of the ellipse of the center of the point is referred as apogee, and the nearest point from the center of the earth is called as perigee. So here in this figure, A indicates the semi-major axis and B indicates the semi-minor axis. So the total radius is the major axis. So from this, the eccentricity is calculated. So eccentricity E of the system can be written as E is equal to square root of A square minus B square divided by A, where A and B are the lengths of semi-major axis and semi-minor axis in that particular ellipse. So for an elliptical path, the value of the eccentricity whose lies between 0 to 1. So from the values of eccentricity, the path of the orbit will be varied. So for an orbit that will be elliptical, that eccentricity values that should be lies between 0 and 1. If the value of A is greater than B, means the value of the semi-major axis is greater than semi-major axis, minor axis. Suppose let us consider if the value of the eccentricity is 0, then if the value of E is 0, then the path will be no more in elliptical shape and that path will be converted to circular shape. So if the the eccentricity is between 0 and 1, the path will be in elliptical shape, and if the eccentricity is 0, the path will be in circular shape. Second is the Kepler's second law. So second law states that the for equal intervals of time, the area covered by the satellite will be same with respect to the center of mass of the Earth. So this is also indicated in this figure. So assume that the satellite covers a point P1 and P2 distance in the same interval. So then when the area of the two areas are represented as B1 and B2, these are covered by the satellite at two instants are equal. So next is Kepler's third law. So Kepler's third law states that the square of the periodic time of an elliptical orbit is proportional to the cube of its major axis length. So mathematically it is given as t square, which is directly proportional to a cube. So where t square, now to remove this proportionality, we are including on constant whose value will be 4 pi square by mu. So here 4 pi mu is the proportionality constant and mu is the Kepler's constant. So they already know that Kepler's constant value, which will be 3.98 0.0005 10 power 14 meter cube per second square. So from this, the we can say the value of n is considered to be mean motion of the satellite in radians per second. So which can be represented as a cube is equal to mu by n square. So we can say that when a satellite revolves around the Earth, it undergoes some of the pulling force or some external disturbances. So that external disturbances will be from the gravitational force from the nearby objects like Earth or other objects. Similarly, it experiences a pulling force from the Sun as well as the Moon. So that when the satellite is launched, when it reaches its orbit and it should maintain in the orbit in correct position, there should be a balance between the two forces should be maintained. So next type of law is Newton's law. So Newton's law it also discusses about the uh, law of satellite launching satellite in space. Newton's first law, which says that an object at rest will remain at rest unless an acted by a force is acted on by it. So and also an object in motion continues in motion with the same speed and with the same direction unless an external force is applied on that. So this Newton's first law, it is also known as law of inertia. So here we can say that the object will be what is the position of the object or what is the condition of the object will be remain as such without any external trigger or without any external force applied on that, it will not change its position. So in order to change the position of an object, we should provide some external trigger. So next is the Newton's second law. So it states that acceleration is produced when a force acts on a mass. So we can say that the mass of the object is greater than the amount of force needed for the acceleration action should be high. So we can say the force should be directly proportional to acceleration. So to remove the proportional constant, the mass is included. So F is equal to m into a. The thing is, if the mass of the object is very high, then the amount of force needed for its movement should be very high. The next is the Newton's third law, the very common law we all know already. We can say that for every action there is equal and opposite reaction. So this is Newton's third law. This means that for every force that is reaction force that is equal in size but opposite in direction. That is to say that whenever an object pushes another object, it gets pushed back in the opposite direction. It should be equally hard. So this can be explained by the rocket engine thruster. So Newton's third law, it states that for every action there should be an equal and opposite reaction. So consider a rocket is going to be launched. So here the front portion which consists of which make the satellites to be moved in the forward direction. So while launching the satellite, it carries a large number of equipments or components like the thrusters, jets, as well as the thermal control equipments, etc. So when the external force is applied on that particular spacecraft, the the back end of the program that will be